So welcome everyone to this HSMA Masterclass, which is going to focus on StreamLit. So we're going to use StreamLit with SimPy, Discrete Event Simulation. We're going to build a very simple front end to the simulation model. And you'll be able to, I think by the end of it, you'll be able to build a StreamLit front end for any of the models that you are building in your projects. The good news is everything we're going to do today is really straightforward. StreamLit is designed to be easier than Shiny. I know you've been exposed to Shiny in R. So it's very, very easy to build StreamLit apps. That comes at a slight cost, as in it's not always as flexible as Shiny and other solutions. But I would say probably 95% of the time it's going to give you what you want, and it's going to give you that a lot quicker than other solutions. Okay. Does anyone have any questions before we start? What we're going to do is try and work to about 10:40, where we'll have a short break, and then we'll see how far we get afterwards. So there's hopefully going to be 2 or maybe 3 group exercises. Dan, did you set up the breakout rooms?
Yeah, so I posted that on Slack. So there's going to be 4 groups. So it'll be a bit different today. It won't be peer support groups. There'll be 4 groups, and when we open those, people can choose which group they want to go into.
Thanks, Dan. Okay, let's share my screen. Okay, so hopefully you can see a web page here, and this is just a web app that we're running online as an example of how you can link StreamLit to any type of data science or operational research model. So in this example, we're working with a discrete event simulation implemented in SimPy. It's a very, very simple toy or stylized discrete event simulation of an urgent treatment center based on an example in the United States. So we have a landing page to that app where there's a bit of information about it, and then we have some pages on the app. And by app, I mean this is something you can run on your phone, you can run it on your iPad, on your Amazon Fire tablet, whatever. It's just a web page you direct to, and StreamLit does a really good job of trying to format what you see on the device that you're using. Now, we have found that sometimes with phones, we need to just tailor things a little bit. But overall, it does a good job out of the box with its default layouts. So just to give you a flavor of the things we're going to do today is we're going to set up an interactive computer simulation model. So here we've gone to the interactive page of the web app. We have some information about the treatment center, which is just an image of the process that we're modeling. So this isn't animated, nothing too clever. It's just a PNG that we've loaded into the web app. So we can see here we've got a classic kind of urgent care type system. You've got trauma and non-trauma arrivals. Some patients need stabilization and treatment. They require resources to do that. Non-trauma medical patients will require registration, examination. They may need treatment or not, etc. We've got resource-bound constraints. And the arrival pattern to this system is uneven. It's a time-dependent pattern. So we've used thinning to implement this in discrete event simulation. So you can see certain types of the day are busier than others. And that's one of the neat things about DES. It's easy to sort of implement those things. So here on the sidebar, we have a number of parameters that we can vary with the simulation model. So for example, we can vary the number of triage bays, the examination rooms. We've got parameters to do with the trauma pathway, so the probability that an arrival is a trauma patient, etc. And we've got information about length of stay in certain parts of the model, how long they stay in examination, etc. And you can control the mean and variance of those. And we've got model execution as well, so we can decide how many multiple replications of the model we're going to run. And then we have a button called Simulate Treatment Center, so we can click on that. Got some information there that it was running the simulation, and out pops some results. We've got, for example, the throughput of the system was 151 patients on average over the day. And then we've got a measure of error and risk plots, which I'm not expecting you to know about, but it's a way of just trying to understand the spread of replications as well as your error. So we can crank that up and get a bit more information out of it. Let's run it for 50 replications. So obviously it's going to take a bit longer to run with 50 replications. We find that the StreamLit online service is pretty good, like a sort of medium powered laptop really. So here we've got some more information about the average daily throughput. We've got the likely range that the replications are going to fall in, and the average, as well as a confidence interval around the average. And then these are the percentiles. So you can sort of mix visualization with tabular output in these things. And what we'll look at in the app is we'll look at something a bit more interesting than Matplotlib. We'll have a quick go with Plotly to produce an app that you can hover over, and it will do different things for you. You could load this up with preset experiments if you wanted to. For example, if you were, if you'd done a study and you wanted to share this with other people in your organizations and you wanted them to be able to run the model and get the same results as you, we could have a situation where we have 6 scenarios and we run the simulation model, and we get across those scenarios a range of performance measures. And if you wanted to, you could download those results as a CSV, or you could copy those results to clipboard and paste into your favorite spreadsheet program for producing tables in reports or whatever. I won't do this today as well, but you could also, for example, have a situation where you upload experiments. Oh, I do have it here. So I can click on a CSV that I've got scenarios in, and it's uploaded 7 scenarios for me. It tells me what I'm varying within those scenarios. I can decide how many replications of each of those I'm going to run, and I can execute the custom experiments. Now I get my results. So if you wanted to provide a way of doing batch experimentation to your organization, you could easily set that up with something like this. A little bit of logic behind here that's a little bit more involved than what we're doing today, but I can share all of that with you. And basically, you can have as many of these pages as you would like within your app. We're just going to focus on building this, an interactive front end to your simulation to enable people to just experiment with the system. Any questions before I move on? Okay, with that deafening silence, I will move on to a bit of an overview of what we're going to talk through. So really, I've covered what is StreamLit, and really what we're going to focus on is this process here. So this is the book that Dan posted on Slack. If you need an easy way to get to it, you can type bit.ly/SimPy, I can spell it, _StreamLit. And that's just a short URL to take you to the book. Okay, and we're in the StreamLit section of the book. So we're going to work through this process. So I'm not going to get you to build the simulation model today. We've got a simulation model for you to use. But what we are going to do is just think about how we set that simulation model up so that it will work with nicely with StreamLit. And actually, the way we're going to set it up is it will work nicely with any front end you want to use. So if you wanted to use something different from StreamLit, it would be no big deal. If you wanted to produce a command line app, it would be no big deal. Okay, so this is just a nice bonus of what we're going to do. So we're going to do that in 2 ways. We're going to build an experiment class that's going to house our parameters for our simulation, for our SimPy simulation model. And we're going to wrap a simple wrapper functions, that they're just high-level functions that sit above the simulation model, and we kind of interact with those functions rather than the simulation model itself. We're going to organize all of that within a Python module. So we're not going to keep our code in a Jupyter notebook. We're going to put that into a module called model.py, and we're going to import our wrapper functions and experiment from that. Once we've done that, we can test that and just check it all works. And then you'll see it's from that point, it's super simple to convert the script that's calling that module into a StreamLit app. And we can do that within a few minutes and a few commands, which is really nice. And one of the bonuses of StreamLit. So the main concepts that we're going to look at is, like I mentioned, we're going to build this Python module called model.py, and that's going to house our logic for our SimPy model. It's also going to house our experiment class. It's going to house a wrapper function which will just perform a single run of the simulation model. And that's going to contain things like creating the SimPy environment, creating the SimPy resources, and starting the execution of the model. And we're going to have a function which calls that called multiple replications. All that's going to be is a for loop that's basically going to repeatedly call the single run function. It's going to receive back results from each of those replications and format them. Okay, so we have one Python module, which will be model.py, which contains all of that code. And then we're going to have a StreamLit script. And you can think of this having kind of three major components. We're going to create an instance of the experiment class. And remember, what experiment does is it houses the parameters of the simulation model. So, for example, it might be the number of cubicles that we saw in the treatment center simulation. So once we've created an instance of that class, you can now have any type of code calling it. So it could be StreamLit or it could be something else. Okay, so within StreamLit, we have input widgets, and we're going to have sliders that we saw and also a numeric input that's going to allow us to vary some simple parameters, and that will update the experiment object. And then when we click on the widget that says simulate, it's going to push that experiment to multiple replications, and we'll see that's just as a parameter. And then multiple replications will pass the experiment to single run, and that will repeatedly run the logic and functions that we've defined for our SimPy model. Once that's done, the formatted results are passed back to StreamLit, and we have a number of widgets to display those. And we saw that with the tabular view and the matplotlib chart there. So the stylized example I'm going to work with is an urgent care call center. So we have calls arriving at random throughout the day. Those calls are going to wait until a call operator is available. Once that call operator is available, there'll be a delay, and that delay is triage, basically. Now, some of those calls will need some of those calls will be designated as seeing primary care. They might go to A&E or might come to nothing. Some of those calls might require a call back for either further triage or advice from a nurse. Okay, so those patients, the proportion of patients that have to wait for those will queue up here and wait for a nurse practitioner to become available. When they are available, there's a consultation, and then they exit the system. So urgent care call and nurse consultation are resource-bound stochastic activities. Okay, so it's classic queuing system. And we've set this model up really simply. There's two functions, arrival generator and service. We can have a quick look at those if you want. Model code. Let's have a look at arrival generator first. So this should be nothing new to you. It should be very similar to how Dan taught things. This is set up just with functions for simplicity. So we have an arrivals generator, that's sampling the next inter-arrival time from the arrival distribution. There's a timeout, basically a delay waiting for that IIT to disappear. Then we print out, call arrives, and we initiate the service process for that caller. And if we have a quick look at the service process, we've got operators, so we're requesting an operator. Once we've got an operator, sample the operator duration, okay, collect a bit of results on the way. Then a proportion of those patients will need a callback, okay, so we sample from a distribution to decide if they need a callback or not. For those that need a callback, they request a nurse, they wait for a nurse, sample a duration from the nurse distribution, and then there's a timeout when there's a delay. So very simple implementation of this model in SimPy, nothing fancy. All these extra bits, trace is just a function that's sitting on the top of print, and we can change a parameter called trace to true or false, and it will just print out the simulation, you know, the details of the simulation model or not. And for multiple applications, you want to turn that off, but it's useful for debugging. So nothing clever going on there is the point I'm trying to make. Okay, so let's take a look at the experiment class. Okay, so I'm flicking over to Jupyter Notebook now. So Jupyter is fine. Jupyter Lab is fine to use for the exercises. You could also use Visual Studio Code if you prefer, but you need to make sure you've got the Jupyter Notebook extension downloaded and activated, otherwise you won't be able to interact with the Jupyter notebooks. We're going to use a mix of Python modules and Jupyter notebooks in this tutorial. So to find this notebook, if you're following along, from the top of the repository, you can go to content, and then we're in 03_StreamLit. And here we've got the Jupyter notebooks, which make up that online book that you've been looking at. We've also got some Python modules, which will build up as we go through. If we flick back up one level, we've got exercises and solutions as well there for the break. Okay, so let's have a look at the experiment class. I'm just going to check this, it's big enough for people to see. Okay, that's a bit better. So I'm not going to labor this too much because you're going to see this is just really a container. Okay, it's a place where we put parameters for our simulation model. And you don't need to use a class if you don't want to. You could use a dictionary if you prefer, or you could use there's something called a Python data class, which is a very specific type of object that you can't change within Python. I prefer classes. I prefer being able to give them a name. I prefer being able to update them if I need to. I use my experiments to collect results throughout the run as well. So I prefer old school Python objects because they're a bit more flexible. Let's just have a quick look down. So what I've done is I've defined a number of default parameters for an experiment. Okay, this doesn't really matter too much, but this is what I like to do, and it means I can very simply create an experiment and run one if I want to. So for example, we've got number of operators here in all caps. So that is a notebook level variable. So you can access that variable anywhere within the notebook. Its scope is the entire notebook. And in a Python module, it would, if you declared that at the top of the module, it would be a module level. It would have module level scope. So you could use it with in any of your functions, etc. Now I can't quite remember how Dan taught sampling within discrete event simulation, but what I tend to do is create distribution classes. So for example, we've got the uniform class here. Now what that does is it accepts the parameters of the uniform distribution as well as a random seed, and it stores them. And it also creates a NumPy random number generator. Okay, so whenever I call sample, I just sample from the distribution, and I don't need to know what the parameters of that are. I can pass that around in my simulation model without having to pass around the low value, the high value, and the random seed. Okay, it's all encapsulated within this object. So the notebook starts by defining a few of those. Feel free to reuse those. And so to create, for example, an exponential distribution, you would call exponential, and you would pass in the mean and the random seeds. Remember, an exponential distribution only has a single value. That returns it as an object. And you could then call the sample method to sample from it. I'll tell you what, let's clear all this, and we'll run some of these cells. Run select, run all above. Okay, so each time if I get rid of the random seed, each time I sample from that, I get a different value. So that would be the objects you would use for creating an inter-arrival time to the simulation. So the experiment class. So you don't need to call it experiment. You could call it scenario. And you'll see in the treatment center simulation model in the exercises, I call it scenario, but it just represents a part of the run. What are the parameters of that particular experiment you're going to run? And you'll see it's really easy to implement. So in the constructor method, what I've done is I've used those module level variables, or notebook level variables in this case, as the default values for a whole bunch of parameters. So for example, number of operators, number of nurses, the mean inter-arrival time, the call operator load time, the call operator mode, and high time, etc. So you read all of those in, and then you create you either store the number of resources you're going to produce, you create the distributions, and in this case, I'm initializing result values as well, because I'm going to store the results of my replication within this experiment. I've done that with a dictionary. So there's not much to it. Okay, and the simpler the simulation model, the simpler your experiment class. The more parameters you have in your model that you want a user to be able to vary, the more complex your experiment class, because you have more potential values to put into it. So example usage. So this is why it's nice to have those optional default values within the constructor. So for the default experiment, we just create an object of type experiment. And if we look at the number of nurses, we've got 9 nurses by default. And we can sample if we need to from the arrival distribution. So that's quite a cool way to set it up, because we could now, for example, very easily vary the scenario. So for example, if we wanted an experiment where the number of operators is increased by 1, all we need to do is pass number of operators equals 14 instead of 13 into the experiment constructor. If you wanted an extra operator and an extra nurse, you would pass in the number of operators equals 14 and the number of nurses equals 10. So if we have a look in the default experiment, the defaults come out at 13 at 9. If we look in the extra operator experiment, they come out at 14 at 9. If we look at the extra operator and extra nurse experiment, we get 14 and 10. So bit of work to set this up. Okay, so we've had to write some code for the constructor. We've built up our classes to represent distributions, but the beauty of setting it up like this is it's now really easy to reuse. Okay, so you could use this in any type of front end. And all you really need are widgets which parameterize these values. And we'll see how to do that shortly. Okay, so that's the experiment class. Any questions about that? Okay. So let's have a look at how we use the experiments with single run function and the multiple replication functions. So we're going to hop over to O4_wrapper. So what we've done is we've popped all of that, as well as those service and arrival distributions, into model.py. Okay, so down here we've got model.py. We'll just have a look at that. So we can see we've got constants and module level variables. So here are those default values I spoke to you about. We've got our distributions. And if I do a Control F, I should be able to find experiment. The experiment class. Here we go. So here's what we had in the Jupyter notebook. We've just moved it over into a Python module. And if I look for service, that's in the SimPy model logic section. Okay, so everything we looked at, it's all there. It's all lumped together in one Python module. But actually, all we need to import is one class and one function from that. And that is the experiment class, which we've already seen, and the multiple replication function. Okay, and we'll take a look at what that looks like shortly. Well, let's see how it works first. So what we need to do, let's just import those. All we need to do is create a scenario. So for example, we're just going to say default scenario equals experiment. And then we're going to run our multiple replications function. Let's see if we can get help up for that. So here's the method signature for multiple replications. You can see it accepts an experiment, the results collection period, and the number of replications. And we can see that the results collection period has a default value of 1000, and the number of replications has a default value of 5. And there's a bit more information about it there. We can also see that it returns a pandas data frame. Okay, so pretty easy to use. We just need to pass in an experiment. Okay, so we've created one there. So we just run it like this. And then we get our results. Okay, and what's come out of it, we can see what's come out of it. We've got each row is a replication, and each column is a performance measure from our simulation. So we've got mean waiting time for operators and mean waiting time for nurses. And if we wanted to, we could call results.describe, and that just gives us the average results for those performance measures, as well as some other descriptive statistics. So we can use experiment with multiple replications by varying the parameters as well. And as I said, that's really easy to do because of the way we've set it up. So we just changed the number of operators here to 14. And then the code to run the multiple replications is the same. Noticed a bug there. Okay, that should be extra operator. We just pass in the experiment and the number, well, if you want to, the number of replications, it will run 5 by default. And then we get our results, so we can see what the effect of varying the number of operators is on our performance measures. So let's have a look at the multiple replications in the single run function. So let's have a look at single run first. So if we just scroll down. This has got the full model. So here's our single run wrapper function. So you should recognize this from the work you were doing with Dan when you were first looking at SimPy. So in it, what we're doing is we're creating a SimPy environment. We're creating a SimPy resource. Okay, we're passing in the environment to that, and we're specifying the capacity. And we kick off a process, which is our arrivals generator. That's the one you always kick off to start off with. And then we run the simulation model until the results collection period. Now, if we look, you can see that the number of operators comes from the experiment that we've passed in. And we know that inside the service and the arrival functions, we're also using the experiment class to sample from different distributions. So you can see that arrivals generator takes both the SimPy environment, but also the experiment class itself. And then at the end of it, we've just got a little bit of analysis of the results here. We're calculating mean waiting time and mean operator utilization. That can be whatever performance measure you desire. But basically, really simple. So we kick off the simulation environment, we create the resources, and we fire off the simulation process. End of story. So that gives us a single replication of the model. And then if we have a look at replications, we can quickly flick down to our single run to the multiple replications function. And you can see this is barely any code at all. In fact, really, it's just this line here. So this is a Python list comprehension. You could also just use a for loop. Basically, what this is doing is it's running the single run function number of reps times. Each time it's putting the results into a Python list. And at the end, it assigns that list to a variable called results. And then there's just a little bit of code here where I'm just manipulating the results from a list into a pandas data frame and giving the columns names, etc. So nothing too important there. But basically, this is the multiple replications function, a single line of code. Okay, so back to our wrapper notebook. So we've seen that it's really easy to create an experiment, and we've seen that it's really easy to then just pass that experiment to a wrapper function that we've set up for our simulation model. So you can start building simple scripts now that you might use to run scenarios of your model, where you set up the number of operators, you set up the number of nurses, the chance of a callback, number of replications, and then you pass all of those to the experiment class. That will create an instance of experiment, which we call exp, and then we run exp number of reps times, and we show the results. Okay, so if we wanted to, we could have a script that we run scenarios with like this really easily. Okay, and you could, if you wanted to, that could be what you provide to user. But I think we can definitely do better than that. Does that make sense? Any questions? Okay, let me just check my schedule, how we're doing. My other computer's gone to sleep. So we're almost at a point where we can do a group exercise. I mean, the only other thing you might do with this is take it and put it into a Python script. So for example, I can just call it model.py. Yeah, here we go. No, that is the model. I'm not sure I built that script. But basically, you would take this, let's copy that. We'll create a new Python file. We'll paste that into it. I'm going to put a print here. And we're going to call that model script.py. So if you wanted to, you could run this script. So let's create a console. Just check. So we should have model script.py. So if I wanted to, if I activate my Conda environment, what I could do now is I could write Python model script.py and run that, and it doesn't work. Name experiment is not defined. Okay. So I'm not quite sure what I'm doing. Oh, I know why. Because I've not imported. Import from model. Import experiment. Multiple replications.
Is there an extra E in front of?
Go back here. I've got an error now. This is why Dan is the master of doing things on the fly and I'm not. Hey, there we go. Okay, so we've got some results. So this might seem like why are we talking about this in a StreamLit tutorial? Because very much this is the first thing you should do before you build your StreamLit app. Organize your simulation model so that it is reusable. You have a script now, which we'll see after the break. We can edit this really simply and turn it into a StreamLit app. Okay, so before we do that, we're going to have the first group exercise. And that is the SimPy treatment sim model. Okay, so what we're going to do is build a script very similar to what I've done with the 111 call center model, but this time with a more complex simulation model where you can vary more parameters. So this has been installed on your computer. If you have followed the instructions for the setup for the module and created the Conda environment, that has downloaded and installed from PyPy a package called TreatSim. So if we flick back here and go to exercises. Let's clear all cells. So you import TreatSim like this. Okay, and then to check the version, just do _version. So I did just update this on Friday. So I'm hoping, well, if you haven't got version 1.0, what you can do is you can type pip install TreatSim equals 1.0.0. And as long as you're in your Conda environment, what that will do is it will try and install the new version for you. It's going to tell me that that is already satisfied because I've got it installed. So then from that treatment sim package .model, I can import scenario, which is the treatment sim equivalent of experiment. So like I said, you can call that whatever you want, and a multiple replications function. And then there's some instructions here about how to create a default scenario, how to vary parameters in that scenario, how to run the multiple replications function, how to describe the results. And then there's a little exercise at the end where I want you to have a go at varying some of the parameters and setting up a little script so it's easy for you to do that. And you could use the 111 call center example that I've shown as a little example of how you might do that. So we're going to have, how are we doing for time? I think we're doing pretty well for time, Dan. Let me just check.
Yeah, I think we're good. We're only 10 past 10, so I think we're bang on, aren't we?
Yeah, a little bit behind where I wanted to be, but let's say we'll come back here at 25 to, and what I'll do is I'll do a quick review of the exercise, and just to make sure we've caught all the nuances of what we've been doing. So if you go into your breakout rooms now, I will grace you with my presence at some point within the next 25 minutes and check up how you're doing. Any questions? Okay, so Dan, do you have to allocate to the breakout rooms?
Yeah, I'll open them up. I'll just pause the recording now, and then I'll open up the rooms.
Great,
So people can choose whichever room they want to go into, and yeah, just pick your room.
Ooh, by magic, recording is back in progress. Well, welcome back, everyone. After a short break. Okay, let me just share my screen. So now we are going to get into the fun stuff. Okay, so about 25-30 minutes now of me talking before you have a go at this yourself, and within the next hour you're going to have your own StreamLit app up and running. It's that easy, let's say. So what we're going to do to start off is we're going to go through creating your first web app, making that interactive, tidying up the controls a little bit. So we're going to add a sidebar, for example, and just loading up a bit of background text from a file that we can show. So once you've got all that, you actually have everything in place to have a really nice looking, simple web app that you can run your simulation models or whatever type of model you've got with your projects. If we've got time, we'll talk a little bit about adding Matplotlib and Plotly to them. But if not, the material is very straightforward and it's all there for you to have a go with. Okay, so I'm going to head back to my instance of Jupyter Lab. And I've got that script file I created, model_script. What I'm going to do is I'm going to import StreamLit. So I'll just do that at the top, import StreamLit as ST. And you'll notice I nearly always write StreamList. The mental pathways are fully reinforced. I do apologize. I just can't get out of that habit. So once we've written import StreamLit, we can now launch a web app. So if I just clear this. So I'm basically in the directory containing that script file. So if I type ls, you can see model_script.py. So if I want to run a StreamLit app based on that script, I can just type StreamLit run model_script.py. Now, note one extra thing. I'm in my Conda environment sim, which has installed StreamLit. So you need the StreamLit software pip installed. Otherwise, you won't be able to run StreamLit scripts. So if I run that, what automatically happens is the web app launches. And there's nothing there because we've added no screen widgets to it. But we've got our first web app, it's launched. If we hop back over to Jupyter Lab, you'll see that it's launched on HTTP localhost port 8503. So that is the port that StreamLit always aims to run on your local machine. The other thing that's happened is we've ended up with some results in our terminal. And if we hop back over to our model script, we can see why. Because StreamLit has run this script, and at the bottom of this script, we've printed some results after we'd run some multiple replications. Okay, so let's add a title to our web app because there's nothing there at the moment. So we can do that using st.title. So st is the alias for StreamLit that we've imported. And this is the urgent care model. I'm just going to save that with Control S. Now, if I flick back to my StreamLit app, which is still running, and refresh it, urgent care call center model appears. So I've not had to turn off my app for the results to appear within it. Now you see, we've got the results again, and that's because I refreshed the app. And what's happened is StreamLit has run this script again. Okay, and again, it's just gone through the motions, done everything we've told it to do in the instructions, and printed out the results at the end. So we're going to stop that by including a button. So this, again, is just another StreamLit widget. So we include a button using conditional logic. So we're going to have an if statement that basically says if this button has been clicked, then execute this logic. So if we type if st.button, and we type simulate in there, what we're going to do is we're just going to indent all of this code now. So StreamLit's going to come in, it's going to print out a title, Python's going to assign those values to those variables, then StreamLit's going to show a button. If that button has the value true, then this code is executed. So if we go back to our StreamLit script and refresh, did I save that? Now it's telling me my source file has changed. So if you click on rerun, the simulate button appears. And if I click on simulate, something has happened. If I click on it again, something has happened. Let's go back to our terminal. We can see we've run the simulation multiple times, but it's still printing the results within the terminal, within just a basic Python print statement. So we can very quickly get those results on the screen by either using one of the output widgets that StreamLit provides. So StreamLit data frame or StreamLit table are good choices. So instead of having a print statement here, we'll change that to st.dataframe, save the results, go back to our web app. It's let us know that we've modified our script. We'll rerun that. Now, when we click on simulate, we get the simulation results outputted. So we've got our performance measures for the 111 call center, and we've got some summary statistics for each over 5 replications. Make sense? So let's just have a quick look at that script again. So you can see why it was important to organize it the way we did, because it's now very simple to manipulate these parameters and get a different scenario using the web app. So I think in here, you won't have model.script, but you should have a file called basic_app. Let's just have a look at that. In that, it's got a slightly nicer formatted version of what I've just showed you. So it shows you where the modifications have come in. Okay, so we can build this up step by step. Now, one downside to what we've done so far is there's no way to vary the parameters within the simulation model. So what we will do is we will add sliders to the simulation model. StreamLit has a whole bunch of different types of input widgets you can use. We just flick over to here, we can have a look at the method signature for slider. So we call it by st.slider, a bit more involved than the other functions. We pass in the name of the slider, which is just a string, and that's the name that's going to show up on the app. We pass in the minimum value, the maximum value the slider can take, the default value of the slider, and the step in between each notch on the slider. So if you want it to be an integer value, you would have it at a minimum of 1. Now, what this returns is a numeric value that'll either be a float or an int, depending on how you set it up. So, for example, for call operators, we would have a slider that would have the name call operators we're going to give it the minimum value of 1, so we can never have no call operators in there. We can have a maximum of 20 call operators. The default value is 13, and we're going to allow the user to vary the number of call operators by 1. So if we copy that, head back to our script and type Control S to save. Okay, we've now modified our script. It's still the same variable name. Okay, so that's going to be passed down to the experiment class and run the replications, but we don't need to modify that code that calls the simulation. We are simply modifying the parameters that we put inside experiment. So if we save that, go back to here, we've now introduced a slider that we can vary up to 20, rerun, and get different numbers of parameters, different results. So we could do the same for number of nurses. Okay, and you could have a different step if you wanted to. They could change the nurses by 2. It normally makes sense for resources to be able to change by 1. We could do the same for the chance of a callback. So we're going to have that go as low as 0.05. It's going to go up to a maximum of 1.0. So everyone will have a callback. Its default value is 0.4 and its step is 0.05. Okay, so I've included this one because it's not an integer value that you're manipulating. So if we head over to StreamLit again and refresh, maybe I didn't save that. Oh. File and save Python file. Not quite sure why it's not detecting the change, but we will just crash it and rerun. And there we go. We've got our 3 sliders included. So we could change this by up to 5% at a time for the chance of a callback. And it's up to you whether you want to include a 0 value, if you want to shut that functionality off or not. You can also include, I believe you can include a help. So you'll see now we've got, a little hover box there. So if you wanted to include some additional information about the slider, you could, no problem. So if we go to streamlit.io, there's plenty of information in there. Ooh. Plenty of information in the documentation about the types of input widget you could use. So if you go to API reference, and you've got input widgets, we've got these different ones we could use. Let's pick a number input for the number of replications, because we might, in theory, run quite a large number of replications, and it's a bit of a pain if you've got to change that as a slider sometimes. So we can see here that we have st.number input as our function. We pass in a label, the minimum value, maximum, the default value, and the step. And then there's other things we can include in there as well if you're interested in that. So let's copy that. Go back to our StreamLit app. We'll change the number of replications here. We'll go for min value, the minimum value really for replications. Maximum value, we could say 1,000. Its current value is 10. And its step is 1. So if we then go back to our StreamLit app and we run, oh, Daisy. We've now got number of replications as an input that we can vary plus or minus, or we could just type in the number of replications that we run. That's going to go away and take a bit longer to run because we're running 100 replications and we get our results popped out. So there we go. That's a really simple interactive app that we've built within 5-10 minutes of setup. So most of the work went in setting our simulation model up, and that allowed us to build a really simple StreamLit app within a matter of minutes. So do you have any questions before I show you a few ways to tidy the app up?
Is it possible to change how things look, so text and things like that on this?
Oh, sorry, that was a little bit quiet.
Sorry, is it possible to change how the text looks and things? So the aesthetic side of it.
It's pretty limited. There are, you can change things a little bit, but it's you have to get down into the nitty-gritty to start doing that. Let's have a quick look at see if there's any simple ways to do it within the functions themselves. So you've got themes, which you need to start changing config files, etc.
Yeah, I think that probably fills what I was looking for. So yeah, I can see font there and colors.
Yeah, but you're getting away from just the basic setup. You've got to go and change config files and stuff like that. But it's very doable.
Thanks, Tom.
No worries. Okay, so let's tidy the app up a little bit. So what we're going to do is if we go back to, I think I've shut it down. We go back to my original app that I was showing you. We've got this sidebar here. Okay, so that allowed me to move the parameters away from here and have them on the sidebar. That's quite useful. We're just making this a bit more spacious. You can focus this on results. It helps a little bit with a phone. So for example, this would be something that would expand or disappear on a phone. You just disappears, and by default, it's probably not expanded on a phone. Although you can certainly manipulate that. So that again is really straightforward to do. We can introduce a sidebar. Okay, so if we go back to our script, we can introduce, hopefully Dan's taught you about with statements within Python, and that's we combine a with statement with what we call st.sidebar to give us that sidebar, and it's as simple as that. So with st.sidebar : and basically a with block just means we can indent all of this code here. If we save that, what that's saying is all of these input widgets are within this sidebar. So if I save that Python file, I'm not convinced it's saving very well, and go back to my StreamLit script, rerun, and everything's moved over to the side. So now when I simulate, I'm running 100 scenarios, it appears within the center of my screen, so I didn't have to scroll down to see it. So it's a personal choice whether you want to do this, whether you just want a few sliders on your main screen, but it's just a simple way to tidy it up. The other thing that's a bit of a pain is if I run it, we've got this up here. What would be nice is something a bit bigger and a bit more obvious that the simulation model is running. So we can do that with a spinner. So here underneath the button, we're going to introduce another if statement, another with statement with st.spinner. So what this is telling StreamLit to do is that each time the button is clicked, it'll display this spinner, which is a little animation in the center of the screen, while the code within there is executing. So this is the bit of code which takes a while to execute. So we'll display something to the user just to let them know that it's running. And then when that's done, we're going to use st.success and just show that the simulation is complete. Okay, so if we run that now, we get this running simulations animation that's popped up just to let us know, and then a done when it's complete, just to let you know that the simulation has finished. Okay, so we just tidied things up a little bit, so it's a little bit more intuitive and user-friendly. Things are on the side now, so you've got a bit more space. All right, does that make sense? So the other thing that we had in this app was we had a bit more text here. Okay, so StreamLit needs to be told what text we would like to display. So you can do that in different ways. You could, for example, just include text within your Python file. However, when you have a fair bit of text, that's a really bad idea. Don't include file worths of text within a Python file. Include them in a separate file, read them in, and then use StreamLit's functions to display that text. So I'm going to show you a very simple example of doing that. If we head back to here. So you may remember early on in the course about basically little simple things about reading in files in Python. So if we created a file, for example, called modelinfo.md, which is a markdown file, and we just put some simple markdown in there, between these double asterisks is bold, single asterisk with a space is a bullet point. Okay, so that's just markdown is just a way of formatting text. So we can store that, and then we can read that into Python using standard Python approaches, such as read file contents. Okay, so here we've got a function that I've created. I pass in the path to a file, and then I use an open statement to read the entire file and return it to the calling code. So here's some code that's calling it. It's passing in a link to a folder called resources and a file called modelinfo.md. And then I'm using the st markdown function to display that to the user. So our markdown file, our StreamLit script would look a little bit different now. So here's our original script, but we've added at the top. Well, first of all, we've added a variable with module level scope that's just the path to our markdown file. That would vary depending on where you stored it on your local machine. We've included the function read file contents. And then underneath the title, we're going to show that in introductory markdown. Now, in my example, it's been pointed out to me, this is really simple. You could probably have that as text within your Python file. This is really useful when you've got a lot of text that you want to display on the screen, and it does not make sense at all to include that within your Python file. It will break all the formatting. So, have we got that here? Basic app, sidebar, app with markdown. Okay, so we've got the actual code here. So I'm going to read it in from my resources folder here, which is just this file. Okay, it contains the markdown. In JupyterLab, you can right-click on that and say open with markdown preview, and that's what it looks like when it's rendered as HTML. Markdown can be manipulated. So, for example, we could turn that into a subheading with double hashtag. And then if we open with markdown preview, it just makes the text bigger. Okay, so plenty of markdown cheat sheets online if you want to take a look. So we'll run this code, I think. So let's go to my terminal. I'm gonna crash this. Clear. And then what was it called? It was called app with Markdown. So StreamLit run app with markdown.py, run that. Okay, now we've got the simple simulation model of an urgent call center process. So you may not want that text that big, you might want it smaller, in which case let's close that. Go back to here. Go back to our code here and we'll set that back to. So this is nice because you don't have to muck about with any formatting rules within StreamLit. You do it within the Markdown file itself. And Markdown's very standard language, loads of help about it online. Go back, rerun our app. And it's just shrunk that down a bit for us. So you could have that on a landing page, giving a bit of instructions about the background to the app, who created it. You could include hyperlinks to documentation that you've got stored elsewhere, web pages, your team page, if it's a team of you building apps like this, data sources, whatever you need, can all be included within Markdown and linked to. Okay, so that's it. You can build your apps really quickly. It works really well if you've laid your code out nicely to start off with without thinking about what StreamLit looks like. So we've got an exercise for you to have a go at, which is in exercises, and it's the Treatment Sim StreamLit app. So what I've done is I've provided a basic script, okay, what you were working on earlier. So we're going to vary the triage cubicles, the examination bays, and the number of cubicles for, I think, non-trauma treatment, the mean of the examination time, and the number of replications. And we run a scenario here where we pass all those parameters in, we run multiple replications, and then we print out the results, and it gives you something like this. So what I'm asking you to do is basically create a StreamLit app version of this that allows the user to vary these parameters and run the simulation model and be presented with some results. And you can decide how you want to organize that StreamLit app. If you want to tidy it up, like I suggested, or explore different things yourself in the documentation and have a go at implementing them. Okay, and there's some suggested exercises here you can have a go with. This one I'm not showing you, but it's so easy that I thought it might be fun for you to just do a little bit of research on streamlit.io to see how you set it up. Okay, so let's just have a look at the time. So we're roughly on time. So what I suggest you do is have a go at these exercises in the breakout rooms, and we'll meet back here at 5 to 12. I will quickly go through an example solution to this, and then we'll have a quick look at adding plots as well. So the exercise was asking you to take the TreatSim app and convert that into a StreamLit app. That seemed to go pretty well. If we have a look at the solution, or suggested solution anyway, so here was the original script. Okay, we've copy and pasted that into something like myapp.py. And what we've done is we've made some, sorry, this is not the solutions, this is the solutions. We've made some modifications, so some minor modifications to it. So the first thing we've done is we've imported StreamLit, otherwise we know that's not going to work. And then we've read in some Markdown and displayed that from a file. So many ways to do this again. If you've copied what we introduced in this course, you've probably reused the read file contents function. which just reads in and returns the markdown as a string, and then we're displaying that with st.markdown. We've also got st.title here, which displays the title of the app. Modification number 2 was we've taken our parameters here and we're setting those using a slider. So we vary that slider, it reruns the StreamLit script, and it assigns a numeric value to each of these. I've used slider here for replications, but again, you might use that numeric text box that we looked at earlier, just so it's easier to specify a larger number of replications. We take those, we set up the scenario. If we've clicked the button, the st button, we show a spinner while the replications are running, and then we show success afterwards. And then we use st.table or st.dataframe to display the results to the user. So what that gives us is a basic app. So if we go to solutions in my StreamLit app, let's run that. So we've got a basic app here up and running. So we've not done any tidying up of it yet. We've just chucked in some sliders. We've chucked in a button that we can run, and it'll output our results as a table for us. We kill that. Go back to here. Our next task was just to tidy that up. So to add in a sidebar. So again, we've just started off from where we got to, and the modification is really simple. We add in with.st sidebar, and then we indent all of our code to follow our Python whitespace rules, rerun the model, which I shall do. What do we call that? App with sidebar. And it chucks everything over here for us. We can now vary whatever we need to run, rerun the treatment simulation, and get our results out. It's just a little bit tidier. And that was it. No, so the only other final thing was if you wanted to look up multi-page apps on StreamLit. So these are really easy to set up. So you run your StreamLit app in the same way. So you StreamLit run, and then the file name of your entry point file. And if you want to add pages, you just create a directory called pages. And underneath that, you introduce additional Python files, Python modules. So for example, if you wanted an about page, you would call that about.py. And in there, you might include some text. So there's a nice example in one of the breakout rooms where a markdown file was stored, that was read in and then displayed on that page. And because you've called it about.py, StreamLit will call the page about. So if we go back to our original TreatSim app, that's exactly what I've done here. So I've got a Python file called interactive simulation.py, and the space in the name, in the file name, is represented by an underscore. So I think if we go to bit.ly TreatSim, and that'll take me. So there's a Jupyter book that goes along with this, with the treatment sim app, to give you some idea of how it works. And there's a link to the repository in there. That's not the app. That's not the app. Where is the app? Repositories. TreatSim StreamLit. That sounds promising. Okay, so I have a overview.py. Okay, and that is very similar to what you've got there, but all it's showing is some information about the app as you load it up. Then I've got a subdirectory called pages. If you click on that, I've got a number of files here. So I've got one called interactive simulation, which I've prefixed with 0. Then I've got preset experiments, which are prefixed with 1. So the number determines what order StreamLit shows it in. The underscores in the name, StreamLit will represent it as a space. And if you capitalize it, StreamLit will also capitalize it. So we can see we've got interactive simulation, preset experiments, etc. And if we go back to the app, you can see that matches up with what we've got here. And there's nothing special about any of these. If you go inside, they're just the same as what we've got here. So we've got a sidebar, and we've got some results being run here in multiple replications. So we've got 10 minutes left, which I was hoping to use just to briefly talk about plotting. But before I do so, I just wanted to see, does anyone have any questions about the exercise that we've just done? No? All good? Okay. So the final thing we might think about doing with our app is adding a plot. So we saw that in the treatment sim model. So if we run that, we get a matplotlib output, basically a histogram of the replications. So we could use matplotlib, but as it's a web app, we might think about including an interactive chart of some description. And that might be as basic as you can hover over various data points and it just tells you, for example, in the histogram, how many values are within that part of the bar chart. So within Python, there are multiple libraries that provide interactive plotting. StreamLit supports a number of them. The one I'm going to show you here is Plotly. I think it's quite good. Other people use it quite regularly, which is why I've chose it. We're going to use the Plotly Express module to start off with, which will simplify the creation of some nice plots for us. So the standard notation for importing that is import plotly.express as px, Plotly Express. So what we're aiming to do is get down to this interactive chart here. So this is just embedded within a Jupyter book online, but it will look the same within your web app. So here we've got the mean waiting time for a call operator back in our urgent care call center model. And what we can do is we can hover over different parts of the histogram, and it just tells us exactly how many counts are within that part of the bar. I've also displayed above there waiting time distribution as a box plot as well, showing the outliers and the median, etc. So that's really easy to do with Plotly. So the first thing I've done is I've run multiple replications. Okay, and that's given me my results. We see I've run 100 replications there, so we've got plenty of them for the histogram. And then to create the Plotly output with Plotly Express, I'm just calling px.histogram. I'm passing in the performance measure I'm interested in. So I've got 4 columns within that results data frame. One of them is called O1 mean waiting time. So that's the mean waiting time for a call operator. So I'm passing in the particular column that I'm interested in. I'm passing in the labels for the value, which is the x-axis here, mean waiting time for operator. And then there's this parameter called marginal, and that specifies this distribution that you can display at the top, which is quite nice to include as well. There's some alternative ones you might want to try out, a violin plot or a rug plot, and you can, I'm not going to go through them now, but I quite like violin plots and for showing the spread of a distribution as well as a histogram. but box plots all good. So this code here creates the histogram and it returns a plotly figure object, a bit like matplotlib will return a matplotlib figure. We can then manipulate that. We can update it because by default it will show a legend. Well, there's only one performance measure in here, so we don't really want to include a legend in there, so we'll turn that off. And then if you're in a Jupyter notebook, you just type the name of the object returned and it will display it. You can also type .show figure as a method and it would display it, which we'll need to do in our app. So the app code really doesn't need to change that much. All we really need to do is pass our replication results to this code here and call the correct StreamLit function, and it will display it for us. So what I always recommend is, for any type of figure, is creating your own function to organize your code. So that's what we'll do with this first. And that will make it nice and easy and clean to modify the bit of StreamLit script that we need to. So these are the steps that we're going to follow. Got 5 minutes. We're going to add in a function called create histogram, and that's going to implement the plotly code. I'm going to alter the width of the page again by setting page config, and that's just going to make it a bit easier to fit the table of results and the chart side by side. And we're going to do that by using st.columns. That's going to return 2 columns, and that's going to allow us to choose what we put in different parts of the display. So it's just a way of organizing your display a little bit. And then showing that plotly chart that we created in create hist is as simple as calling st.plotly_charts. So this is the modified file. So we've added in our plotly function. Okay, and all that's doing is calling px.histogram and returning the figure. Okay, I've got some parameters in there, so the results, the column name, the value name, label name, etc., that you can vary and play about with. We're updating the page settings using st.setPageConfig, and the main thing to change is this, layout to wide, and that's just going to help us have those 2 side-by-side charts and table. And then we go all the way down to displaying results. So we've run our simulation model, we've shown done. Instead of just going straight into st.dataframe, we've now got quite a bit more code. So we're calling st.columns to create 2 StreamLit columns, and we're calling those col1, col2. And then we're adding an expander. You'll see what that looks like, but that's just a container that we can open and close that contains our table of results. By default, it's open, and we pop in there the data frame. And we're doing the same for the histogram, our plotly histogram in column 2. So we create our histogram, and then we call st.plotly_charts, pass in the figure, and to help with auto sizing, you can pass in this parameter here, use container _width equals true, and that's just going to change the size of your plotly chart so that it fits within the size of the screen that StreamLit has allocated. So all of this code is in the GitHub repo. If we go to O3 StreamLit, we've got 10_adding plots as the notebook, and we've also got app with chart.py, which is our StreamLit script that we've just been through, that we can run and see what the app looks like. Let's kill that. We'll go cd.dot 3 StreamLits. StreamLit run app with chart.py. So now we run our simulation model, and here are our results. So we have our table of results, and we have our histogram, which is always the mean waiting time for operator, because that's what we've hard coded into the app. So an obvious question is, I would like to vary this. I would like to change the performance measure that is being shown in this histogram, because I've got several performance measures here I would like to display. So there's a number of ways to do that, some of which are more complicated than others. The easiest way is to get Plotly to do it for you rather than StreamLit. So I have a final example which I won't go through in detail, but if you are interested, you can go to the filtering results notebook. And what that will do is it will show you the code to produce this chart here, where we can select different performance measures, and it will change the chart for us. So we can't use Plotly Express to do that. We have to use Plotly graphical objects to do it. But the code itself is not too complicated, and I've included that here for you to have a play about with. And once you've built that, you would just embed it into your app in the same way we did with this one. You would just replace the function that creates the app. Okay, Dan, that is the end of the masterclass. So sorry we didn't get a chance to have a go at the exercise for plotting, but I think it was well worth spending the extra time going through the basics. And now it's just a matter of expanding your horizons, really, and there's plenty of documentation out there to decide what you bring in.
Fantastic, thank you, Tom. That was really good. I found that really useful. I think it's just to say, moving forward, so for next year's HSMA, we're gonna build this into the core training. Certainly StreamLit, probably a bit of Shiny as well, although maybe the other way around, seeing how complex Shiny was compared to this. I think it's good to start with this one. But I think one thing that might be useful actually would be to have, we're going to look to expand the SimPy training to have another session next year. And I think it might be useful to have the kind of building a lot of the model setup, getting your model ready for web apps, because I think that's a useful thing to do in itself. And then obviously that gives us more time to explore some of the Shiny stuff, StreamLit stuff as well. So but yeah, I thought that was really useful, and hopefully that's something that everyone who's doing a project this year will consider using, because as Tom's shown you, once once you've structured your model and you're in a fortunate position that you are just on the outset of your model building, so this is a good time to be thinking about structuring your model. Once you've got that structured in the right kind of way, actually it's really easy to build a very effective StreamLit app, as you've seen this morning, with a description of what it does, some controls to change the parameter, and some outputs. Those are the basics, and then you can build up as much as you want around that, but really quick to be able to do that kind of stuff. Brilliant, thank you once again, Tom. That was a really good session, and yeah, I look forward to seeing some StreamLit apps being developed.
Yeah, me too. Yeah. Good luck, everyone.
Brilliant, thanks everyone. Just say I'll obviously this is recorded, so I'll get the YouTube recording up in the next couple of days, and I'll post on Slack when that's been done too. Brilliant. Bye. Thank you, everyone.
Cheerio.
Thanks, Tom.